Good evening, dear friends. In this particular video, I am very interested in presenting a comprehensive overview about the study of steam nozzles. Anyhow, in my earlier videos, I have covered information pertaining to thermal analysis of heat engines, gas turbines and jet propulsion, vapor power cycles, refrigeration and air conditioning, and reciprocating air compressors. But in this specific video, I am very much privileged to give information about the study of steam nozzles. Dear friends, you all know that nozzles and diffusers, they are very prominent thermal engineering applications. But we are not highly bothered about the study of diffusers. Anyhow, I will mention one or two information about it, but we shall know more about nozzles. What exactly is this nozzle? Where exactly it is applicable? What are all the analytical ideas we need to come across? Let me tell about it. In a very simple way, lucid way, crystal clear way, a nozzle is a energy transforming flow passage. Basically, it is energy transforming flow passage with varying cross section, but eventually, what exactly will happen? Due to the reduction of pressure of steam, there will be increase in velocity. At the end, high velocity jet of steam will be produced. Okay, but just colloquially telling about steam nozzle will not help. Thermodynamically, we should be aware of the principle of operation. Fine, you will question me. Anyhow, a nozzle is an energy transforming flow passage with varying cross section responsible to develop high velocity jet of steam due to the reduction of pressure. But what are the various forms of nozzle we have? What exactly the principle of operation? What are the applications of this? We need to be aware of. But let me tell the application first. Then you will be in a position to know the principle of operation very meticulously. Friends, you all know that a nozzle, you can start from a very simple application like a water pipe, a jet, like that. Okay, but in the sophisticated application, it is expansively employed in jet engines, rocket propulsions, flow measuring devices, and whatnot. Okay, so what is the exact principle of operation? Very simple. You should be aware of a flow measuring device called venturimeter. You might have studied in fluid mechanics. What exactly is a venturimeter? Venturimeter is basically a flow measuring device. Flow measuring, you all know that you will be in a position to measure what? Discharge of the fluid. That is Q. You all aware of the very popular continuity equation Q equal to cross sectional area into velocity of the fluid. Based on that idea, we will be learning nozzles. Okay, but in a venturimeter, what are all the portions we have? Normally, in a venturimeter, we find convergent and divergent cones. Okay, let me be very specific. When you study nozzles, you find three categories. What are those? Convergent nozzle, divergent nozzle, then convergent divergent nozzle. We have three forms. But when we take up convergent nozzle, what is the idea? You know that in the case of a venturimeter or in a turbine, high pressure water or steam enters at the inlet, okay, at the entrance. Once when high pressure low velocity fluid enters a venturimeter or any flow measuring device, it enters a section called throat. Anyhow, for humans, throat is very important for easier digestion. Very similarly, in the case of flow measuring devices, jet engines, rocket propulsion, we have nozzle. At the convergent zone of the nozzle, what will happen? High pressure fluid enters, but at the throat, expansion process will take place. You all know that during expansion or throttling, what will happen? High pressure, low velocity of fluid will be metamorphosed into what? High velocity, low pressure fluid. In the study of steam nozzles, please remember that we are bothered about the determination of jet velocity. We have a very popular derivation based on the study of jet velocity in nozzles. Okay. Also, we will be coming across effect of friction. Fine. Bearing this aspect in mind, the same idea we can take up even in studying divergent zone. What exactly happens in the divergent zone? Just now I told about convergent zone. At the convergent zone, we expect high pressure, low velocity jet. Okay, we do not pronounce it as jet. Normally it is at high velocity condition. But at the entrance, what normally will happen? High pressure, low velocity jet. But after expansion in the divergent zone, what normally will happen? High velocity, low pressure we expect at the divergent zone. Okay. So, convergent and divergent zones are very important in the study of nozzles. This is what the same application we encumber with flow measuring devices. Alright, this is about nozzle. We came across the definition, principle of operation, types of nozzles. But very similar to that, we have yet another equipment called diffuser. Why do we study nozzles and diffusers? Very similar to refrigeration and air conditioning. Refrigeration and air conditioning, normally it is meant for artificial cooling. Here, in the study of nozzles and diffusers, we study with the two thermodynamic parameters. One is the pressure, the other one is velocity. We don't bother about temperature here. Okay. What normally will happen in the case of diffuser? Please remember, in the case of diffuser, we normally give importance for pressure rather than velocity. Okay. In the case of nozzle, we normally emphasize on velocity rather than pressure. Okay. So please remember, nozzle, high velocity jet of steam. In the case of diffuser, we normally expect pressure parameter. Okay. Alright. Do we have types of diffuser? Yes. Axial diffuser, subsonic diffuser, radial diffuser. Very similar to the principle of operation of a centrifugal compressor. In the case of centrifugal compressor, when students study in turbomachinery, the rotating component, what we call it as impeller, we find casing, very similar to the centrifugal compressor. Even in the study of diffusers, we come across the same component. Okay. So, we are aware of the distinction between nozzle and diffuser, types of nozzles and diffuser, then what are the applications? Just now we have emphasized. But is there any derivation pertaining to nozzles? Yes, friends. As I strongly mentioned, when we study very comprehensively about steam nozzles, we come across a parameter called velocity. So, it is very evident that we have to take up a derivation based on the calculation of velocity. Okay. I think you even remember basic thermodynamics. We have come across a very popular equation, steady flow energy equation, which is abbreviated as SFE. Okay. While solving problems on turbines, compressors, nozzles, condenser, boiler, did we not make use of steady flow energy equation? Yes. Even in solving numerical problems on steam nozzles, please bear in mind the use of thermodynamic data handbook. may be employed. It is not mandatory. Please bear in mind we should be aware of the values of enthalpy. Okay. Once when we take up the term steam, obviously we encumber with enthalpy. Okay. So when the values of enthalpy are very much familiar, we can very evidently use steady flow energy equation. By the application of steady flow energy equation, one can calculate the exit velocity at the nozzle. Okay. Always remember the exit velocity at the nozzle will be extremely greater than inlet velocity. For example, if the exit velocity is say 600 meters per second, the inlet velocity will be 1/10 of it. It may be hardly 50 to 60 meters per second. So that is why, friends, learning fundamentals in basic thermodynamics play a very significant role in knowing the expansive applications of thermodynamics. The very obvious thing we are even learning in steam nozzles. Okay, so one should be aware of the derivation of velocity. They should be even aware of the effect of friction. If these things are very much clear, even you will get a connection with compressible flows. Okay, you have already come across in fluid mechanics about compressible and incompressible flows. Even in the comprehension of computational fluid dynamics, we come across compressible and incompressible flow. Okay, so to study about steam nozzles, you should be aware that depending on the fluid flow behavior, density will change. That is what compressibility comes to picture. Okay, so friends, this is all the epigrammatic overview about steam nozzles for the UG based curriculum applied thermodynamics. Okay, all right, I think whatever information I have mustered in this video, it may be easily fathomable, but for about a minute or two, let me quickly summarize what are all the information I have strongly emphasized. Okay, as I said in this video, one will come across the study about nozzles. Okay, compressible flows and nozzles, they are interconnected. So in the study of the course applied thermodynamics, this is one of the modules what we need to study with reciprocating air compressors. Okay, so initially one should be aware about the definition of nozzle. Okay, so what is the definition of nozzle? Nozzle is a energy transforming flow passage with varying cross section. Eventually what we need to emphasize? Development of high velocity jet of steam. If this definition is clear, I think you don't find any difficulty at all. Okay, later on you should be aware about convergent, divergent nozzles types. Okay, later on the prominent applications of nozzle I have already emphasized. Later on, knowing the definition of nozzle, one should be aware about diffusers also. Okay, in nozzles we emphasize on velocity, in diffusers we emphasize on pressure. Okay, later, as I clearly revealed, when we need to solve problems on nozzles, you should be very proficient about steady flow energy equation. Just by using the values of enthalpy, potential energy, kinetic energy, one can easily solve the values of velocity. Okay, but what point did I emphasize? If you remember, in the study of nozzle, the exit velocity of the fluid will be extremely higher than of inlet velocity. That information you should bear in mind. Okay, the numerical problems are very simple. Okay, you have already come across in the basic level of thermodynamics, but I think in the study of applied thermodynamics nozzles, you don't find any problem at all. Okay, you should be aware of steady flow energy equation, the concept about enthalpy, and how exactly you can substitute the values and maneuver it. Okay, that is all about nozzles. Okay, I think the information are clear. Even you will find lecture notes, very popular videos delivered by very famous professors. Also, you will find variety or various links in studying nozzles. Okay, thank you very much for the opportunity in delivering information about nozzles. Thank you very much. Wish you good luck.